Hi guys, so today we are going to learn the concept of overlapping sets. Okay, you might also know this as Venn diagrams, the concept of Venn diagrams. Again, this is a basic concept builder video, so we will focus only on two variable Venn diagrams. Okay, there are four variables that we will cover in the next part of this video series. Today we are going to focus only on two variable Venn diagrams. Okay, so let's begin. So talking about Venn diagram, right? Obviously everybody knows or we know how to draw a Venn diagram. Let us understand what the meaning of everything is and let's understand it conceptually in detail, right? So for two variable questions, although there are three ways that you can solve the question, you can make a Venn diagram, you can use your basic formulas, or you can use the matrix table. Okay, this might be something new for some of you, so I'll explain this in detail. It's one of the easiest method to solve all of these questions. Okay, so talking about Venn diagram, the two variable Venn diagram, we draw like this. This is set A, this is set B, this is my total set, right? As you can see, my Venn diagram has been divided into four parts. This is say portion X, Y, Z and W, right? So what do we understand from X? X means people or variable who belong to set A. Okay, see this entire circle A is called set A, entire circle B is called set B. T is my total set. Anything, the concept of set is very simple. Anything that belongs to A will be part of its circle or square or triangle, whatever figure you make. Similarly, whatever is part of set B will belong to the circle or triangle or square of set B. Okay, so let's understand the meaning of X, Y, Z and W, right? X means only A, people who belong to A but not B. See, X is part of set A but not a part of set B. So X belongs to only A. So these are students or person or variable who are part of A only. Similarly, Y becomes only B, right? They are part of B but not part of set A. So Y becomes only B. Z, right? If you think about it, Z is they belong to both A and B. Who are Z? These are people who belong to both A and B. W, people who do not belong to A or B, right? So they belong to neither A nor B. So they are outside but they are still part of my total set. Okay, this is the basic understanding of set. Okay, let's look at this in further detail. Alright, so again, if we focus on our Venn diagram, right, let's try to figure out what is it about, what are the meaning of each and every variable, right? So as we discussed already, X means only A, Y means only B, Z means both A and B, right? W means neither A nor B. Okay, neither A nor B, right? Continuing from here, Nick, this is where you will continue from. Okay, alright. So we have already seen the meaning of X, Y, Z and W. Okay, let's think about this in more detail. If we say how many people belong to set A, so people belonging to set A means they are part of entire A. So that is X plus Z. Likewise, if I say set B, people belonging to set B, that will be Y plus Z. Okay, people belonging to exactly 1, So see who all belong to exactly 1. So that is your x and y. So x plus y. People not belonging to set A. Not belonging to set A will become total not A. So if I hide A, what is left? Y and W. Okay, don't just say Y. Okay, don't just think Y. Not belonging to set A, you have Y and W. So likewise, not belonging to set B will be Z plus W. Okay, so we say people not belonging to set A, that's Y plus W. Not belonging to set B is Z plus W. Okay, people belonging to either A or B. This is basically your union. Okay, this is basically, theoretically it is called A union B. That means belonging to either A or B or both. So that is x plus y plus z. Okay, that is x plus y plus z. And people belonging to both this z, this is called A intersection B. Okay, this is called A intersection B. This means people belonging to both A and B. People common to both A and B. Okay. Alright. So alright then, let's learn how to solve questions using the Venn diagram or how to use formulas using the Venn diagram. Okay. Right. So again, if a question comes, right, and you want to solve it using Venn diagram, you just equate the variables to the values. So if they say that A contains 40 people, so you can directly write A means x plus z is 40. Or if you want, here also you can write 40. Okay, here also you can write 40, which basically tells you that okay, x plus z is 40. If they say B is 50, so you can write 50 here, y plus z is 50, right? We'll solve some questions using this, so you understand how to use Venn diagrams to solve the questions. You can also, as I said, memorize formulas which use this concept. So the first formula that you need to know is total is equal to A union B plus neither. Okay, total, again if you look at the Venn diagram, right, total is, right, W plus X plus Y plus Z, right? What is total? Total is all the variables combined, that's W, X, Y, Z. If you look at A union B is X plus Y plus Z. If you remember, this is what we did in the previous part. We wrote that okay, A union B means either A or B or both, so that is X, Y, Z. W is left, that is why we add neither, which is W. Okay, next formula, which is the most common formula, A union B is A plus B minus A intersection B. A plus B minus A intersection B. Okay, again if we just look from the variables and see, A union B now we know is X plus Y plus Z. A is people who belong to A, that's X plus Z. B, Y plus Z. Now you can see Z has been counted 2 times, Z has been counted 2 times. So that is why we subtracted once, so that we get XYZ once. Okay, so for all the questions you can either use the Venn diagram or you can use formula. However, as I told you in the beginning, there is another method which is much simpler and can be used for all question types, right? So let's move to that, the matrix table, and see how that works. So if you see, right, this is our Venn diagram, right? So the way to make a matrix table is I will write A naught, total, B naught, total. Okay, and right, this is my matrix. Okay, what each element here means is it belongs to the column and the row. The way you read any matrix, right? You read row versus column, right? So value here basically means it belongs to B and belongs to A. So from your Venn diagram, if we see, this means Z because belongs to both B and A. Okay. Similarly, if we move to the next one, this means belongs to B but does not belong to A. If you look at the Venn diagram, belongs to B but does not belong to A. That's why. Coming to the next element, belongs to A but not to B. Belongs to A but not to B. That is X. You can also call it only A. This does not belong to A or B. That's your W. Okay. So advantage of this method, you will see everything is here itself. So you don't have to worry about what is total A, what is total B. Everything will be written here itself. Right. So if I look at this element now, that's B total. So that's total B, which is simply addition of these two, Z plus Y. This is total not B, that is X plus W, which is total and not B. This is total A. Total A is X plus Z. Total not A, which is Y plus W. This is your total, which is W plus X plus Y plus Z. Okay. Now, one advantage of this method is, see, your total from here and from here needs to match. So if you're making any calculation mistake, you will understand that, okay, my total is not matching. I have made a calculation mistake. Let me correct that. Okay. So this way, this method is useful. Another important use case. Okay. I hope you are able to make the table and understand it. Another important use case of this table is min-max questions. Okay, questions related to minima and maxima. Okay, in a Venn diagram, sometimes it is little difficult for people to understand how to minimize this, how to maximize this, and we tend to memorize it. Okay, so instead of memorizing, let's learn a very simple way and logically we can solve. Okay, so if I want to maximize, okay, let's start by thinking about maximizing. Right, this is maxima. Okay, so if you want to find the maxima, all you have to do is observe the values. Okay, finding the maxima is very simple. All you need to do is observe the total values. Okay, so say for example, from this table I want to know what is the maximum value of A and B, or maximum value of B but not A. That is, Y needs to be maximized. Okay, so if I want to maximize Y, I will look at the total value here. I will look at the total value here. Okay, say this is 50, say this is 35. So I know the maximum value can be 35 only, because post 35 there is no value of B. Okay, so to find the maximum value is very simple in this matrix table. All you have to do is observe the values. Okay, you observe and you get the answer. Okay, we'll be solving questions, so you will understand how to apply this in a much easier manner. Okay, similarly, now if I want to say, if I want to minimize, right, I want to find the minimum. So finding a minimum directly is not possible. Instead, what we do is we find the maxima of the adjacent. Okay, we find maxima of adjacent values. Okay, and from that we derive the minima. Okay, Again, finding maxima is also observation. So quickly observe the nearby value and then solve and find minima. So same, say if I want to minimize y. Okay, if I want to minimize y, so what we do, I can't find this directly. What are the values adjacent to it? These two. So either I find the maximum value of z or I find the maximum value of w. Okay, obviously I'll have the total values given. Using that, I will find the maximum value first, and from that I will derive the minimum value. Okay, so that is why I'm telling you this method. See, easy questions you can solve using Venn diagram, no problem. The help or what we need basically is how to solve the difficult questions quickly, right? That is when this matrix method will help you a lot. Okay, all your maxima minima questions you can simply look and answer. You won't need to solve a lot or think a lot. The table will do its job for you. Okay, if you, I hope you understand this. If you do, then let's move to the questions. I hope you have read the question. Alright, so what we know here is that there are total 120 students in the class. They are either studying physics, chemistry, or neither of the two. 80 are taking physics, 55 are taking chemistry, 30 study both. Okay, so it's your basic two variable question. Let's try this by making a Venn diagram. Then we will see how to solve this using the matrix method. So this is my Venn diagram. Total there are 120 students. Some people study physics, some study chemistry. Okay, physics I know total is 80. Chemistry I know total is 55. Okay, 30 students study both. So 30 students will come here. Right? So total physics is 80, out of which 30 are already here. That means the remaining 80 minus 30, 50 will come here, who will study only physics but not chemistry. Similarly, 55 people study chemistry, 30 study physics also. So remaining 25 will study only chemistry. Okay, let's jump to the question then. How many people are taking only one subject? So if you look at only one subject, that's 50, which is only physics, and 25, which is only chemistry, hence 75 in total. Okay, so this is how you will make Venn diagram to solve the questions. Do the same question but using the matrix method. Okay, let me show you how we solve the same question using matrix method. So I will write, see, I have the same variables and values, 120 students, 80 physics, 55 chemistry, 30 both. Okay, so I will write people who study physics, do not study physics, total. Chemistry, do not study chemistry, total. Total I know is 120 students. Okay, 80 study physics. From here itself I can tell 40 don't. 55 study chemistry, so 65 don't, right? And 30 study both. So 30 will come here, people who study both physics and chemistry, right? Now again see, my total is 55, this is 30, simple subtraction, 25, total is 80, 30, simple subtraction, 50, 65, 50, 50. Okay, my table is complete, right? Now what do they want? People who study only one subject. So if you look at it, only one subject, physics but not chemistry, and chemistry but not physics. So that's again 50 plus 25, 75. Okay, so it's the same question that you can solve using the matrix method. Okay, I hope you understand how to apply both the methods to solve the questions. Alright, I hope you have read the next question. Again, it's similar to what we did, but now we have percentages. Okay, so again, nothing really changes because of percentages. Okay, your method will still remain the same. So we have 300 people employed, 60% company A, 50% company B, 20% use both. Okay, 60% company A, 50% company B, 20% use both. Okay, now read the question carefully. They want percentage of employees. So what we do, again, let's make our table. Okay, we have people using company A software, not A, again total, B, not B, and again total. Now instead of focusing on the number, okay, just focus on the percentages, right? Total percent is 100%, okay, 60% use company A, so that's 60%, which clearly tells you 40% don't use A. Company B, 50%, that means the remaining 50% don't use company B. And we know 20% use both. 20% use both. Okay, that's it. All the data is there. Let's just add, subtract, complete the table. This is 50, this is 20, this becomes 30, this is 60, this is 20, becomes 40, 50, 40, 10, 30, 10, 40, cross check also done. All the calculations are correct. Now, what do they want? The percentage of employees with neither. So the percentage is 10. I don't need that 300 at all. Okay, I hope you understand how we used the matrix. So you might be wondering that why am I pushing the matrix method again and again, right? So this is the question that will tell you why this method is very good. Okay, so if we read the question again, right, there are a total of 70 members, 50 like hiking, 45 like cycling. See, this is a maxima question. Okay, they want to know maximum number of people who do not like anything. Okay, so what we do, same, make your table, make the matrix. So we have hiking, people who like hiking, not hiking, total, cycling, not cycling, total. Now we know total, there are 70 members, 50 like hiking, clearly that tells you 20 don't, 45 like cycling, which tells you 25 don't. Okay, now what are we supposed to do? We have to find maximum number of people who like neither. So this needs to be maximized. Okay, this element needs to be maximized. Now if you recall, what did I say? For maximum, all you have to do is observe. See, total here, maximum total here is 20, maximum total here is 25. So this value can only be 20. Okay, because when this is 20, this becomes 0. Okay, if it is more than 20, this will become negative. Okay, for example, if I say how about 25, because between 20 and 25 you might think 25 is the bigger value, right? So if I take this as 25, this becomes 0, which is fine, but 20, 25, this becomes minus 5. How can you have negative number of people? Okay, so for that reason, right, we observe and we pick the smaller of the two values. Okay, we pick smaller of the two values. So the maximum value is 20. Okay, so this is the advantage of this method. You can simply observe and solve the maxima. Alright, moving on to the next one. Again, you see, it's a minima question. We have 1000 students, 600 science, 550 math, and I need minimum studying only science. Okay, so we'll make our matrix. Students who study science, not study science, total. Math, not math, total. Let's start filling the values. Total 1000 students, total science 600, total math 550. So I know 6600, non-science 400, non-math 450. Okay, again, what do I want? I want only science, means they study science but do not study math. I want this to be minimum. Okay, now if you remember at the beginning I told you we can't directly solve for minimum. If this is minimum, the elements next to it, they are both maximum. Okay, if this is minimum, the elements next to it, they are both maximum. Okay, and we know how to solve maximum. We know we can just observe and find the maxima. 400, 450, maximum value here is 400. Similarly, 600, 550, maximum value here is 550. You can use any of the two and say minima is 50. Okay, minima is 50. Now that you have read this question, you will realize it is based on the application of previous two questions that we did, right? We need maxima, minima both in this. Okay, so again, we just make our table. We have 200 students in total, 120 play football, 90 play basketball. We need both minimum and maximum who play both the sports. Okay, who play both the sports. Alright, so these are people who play football, don't play football, total, basketball, not basketball, and again total. Right, this is total 200. Okay, total 200. Okay, 120 football, that means this is 80. 90 basketball, that means this is 110. Okay, again, what do we know? We need to do maximum and minimum of who play both. So when this is maximum, as you know by now, we can simply observe 120, 90, maximum is 90. Okay, maximum is 90. Okay, now if you want minimum, okay, if you want minimum, you can't find minimum directly, you maximize the adjacent elements. Okay, so if I want maximum of this 80, 90, maximum is 80, 120, 110, 110. Again, you don't need to do both, you can do one and then also find the answer. Okay, you can just do this as 80 and directly say 90 minus 80, 10. Minimum is 10. Okay, or you can do 110 minus 120 minus 110, again that is 10. So you know the minimum is 10, maximum is 90. Alright, now if you have read this question, there is a interesting line that you need to focus on. Okay, so we have 480 students. They are taking at least one of the two courses. Okay, at least one of the two courses means there is nobody who's taking neither. Okay, everybody has to take either biology or chemistry or both, but there is nobody who will take neither. Okay, this tells you that neither is zero. Okay, this tells you that neither is zero. Okay, we also know that the ratio of the students is 2:3. 150 take both. Question is, how many do only chemistry? Okay, so let's continue with our table. We have people who take biology, not biology, total, chemistry, not chemistry, total. Right? Biology, not biology, total, chemistry, not chemistry, total. Now before I solve, let me write this down so that don't forget. Neither is zero because everybody is studying either biology or chemistry. So neither is zero. Then there are total 480 students. Okay. 150 take both the subjects. So both is 150. And I know chemistry and biology, the ratio is, biology and chemistry, the ratio is 2:3. Okay. So the way we solve ratios, we will take biology. So we have biology by chemistry as 2:3. So we will take biology as 2x, chemistry as 3x. Okay. Now let's simply, all the data is given. Let's fill the table. This I can write as 480 minus 2x, 480 minus 3x, 480 minus 2x minus 0. That's again 480 minus 2x, 480 minus 3x minus 0, 480 minus 3x. Okay, so we have completed our table. Now what we do, you can simply make an equation either for this column or this row, essentially any column, any row. Okay, you can pick any column. Okay, so we can pick this column, solve for this, or we can pick this row and solve for this. Right, so we have, I am taking the equation for chemistry. 150 plus 480 minus 2x is equal to 3x. 630 is 5x. 126 is x. We solve that, we get x as 126. Okay, but the question does not stop here. Okay, 126 is an option, but the question does not stop here. Read the question line. What do we want? We want only chemistry. Okay, only chemistry are these people, right? Only chemistry are these people. So you'll have to do 480, right? You'll have to do, right, 480 minus 2 into 126. Okay, that should be 228. Okay, that is 228. Alright, I hope you have read the question carefully. Right. So they say there are total 500 households. Simple. 200 stream service A, that is also okay. 120 A but not B, that is also fine. Now this line is super important. Okay, this line is the game changer, right? For every household that subscribe to neither, 5 subscribe to B but not A. This line is super important. Okay, we'll come back to this when we fill our table, right? But that line is where we need to focus a lot. Okay, alright, let's start with the table. I have subscribe to A, don't subscribe to A, total subscribe to B, don't subscribe to B, total. Total is 500. 200 out of those subscribe to A, which means 300 don't. 120, sorry, my bad. Right, sorry, my bad, I read too fast. Right. 500 subscribe to both, that's your total. Sorry, not both, 500 is your total. 200 subscribe to both, so 200 will come here. Okay. 120 subscribe to A but not B. A but not B. So this 200, 120, I can simply write this as 320, 500, 320. This becomes 180. Okay. Now comes our important line. For every household that subscribe to neither. Okay. So if you have one person subscribing to neither, for that one person you have 5 who subscribe to B but not A. Okay. So for one person who does not subscribe to any, there are 5 people who will subscribe to B but not A. But again, I don't know how many subscribe to neither. So let that be X. So B but not A becomes 5X. Okay. Now again we can simply solve this. 5x plus x is 180, x is 30, right? X is 30. So this is 30, this is 150, 350, 150. What do we want? How many subscribe to neither? Neither is 30. Okay, neither is. Alright, I hope you have read the question. So here we know we have 40% of the participants are female. Okay, some of these are experiencing side effects. 30% of those who report side effects were female. This line is again important for us to understand. Okay, we'll come to that. Let's start with the table first and write down whatever we know. So you have female, male, total, side effects, not side effects, total. Again, if you remember a couple of questions ago, we did that if percentage is given, you can directly assume total as 100%. I know from line number 1, 40% are female. That means male are 60%. Okay. Now, reading this line is important. It says 30% of those who reported side effects were female. Okay, so don't rush and say, oh, reported side effects is given, female is given, so 30 will come here. Okay, do not rush and do that. Okay, do not rush and do that. Okay, try and read and understand the statement. Okay, the statement says 30% of. See, whenever you are reading percentage, okay, read what, focus on the word of, because it's not 30% of total, it is 30% of those who report side effects. Okay, it's not 30% of total. Okay, it is 30% of those who report side effects. So if my side effects, I don't know how many, is X. Okay, 30% of these are female. So 30% of X are female. Okay, remember, again, do not rush and say, oh, reported side effects is written, female is written, so it will come here. It comes there, but what is it? It's not 30% of total 100%. It is 30% of those who report side effects. Since I don't know that, I am taking that as X. So then this becomes 70% of X. Okay, this becomes 70% of X. Okay, now what do they want? the ratio of side effect rate to female side effect rate. Okay, what is side effect rate? Okay, that is simply people who have side effects by total. Okay, so for female it will be female with side effects. Okay, that will be female with side effects and total female. Okay, so side effect rate for female will be 0.3x by 40%. Similarly, side effect rate of male will be 0.7x by 60%. And what do we want? We want the ratio of this. Okay, the ratio means you can flip and multiply. So that's 60% by 0.7x. X cancels out, right? 40 cancels out, right? X cancels out, decimal gone. Okay, percentage cancels out, that's 0 cancels out, that's 18 by 28, which is 9 by 14. Okay, 18 by 28, which is 9 by. Alright guys, if you have read this question, you will realize it is similar to the previous one. Okay, the wording is important. You see percentage, focus on the word of. What is it of? Okay, so we have 15% of motorists committing traffic violations and receiving penalties. Okay, 25% of those who commit violations do not receive any penalties. Okay, so again, table, commit a violation. Okay, motorists who are committing a violation, not committing a violation, total. Okay, receiving a penalty, not receiving a penalty, total. Okay, again total is going to be 100%. 15% of motorists, so 15% of what? Of total motorists commit traffic violations and receive penalties. So this will become 15% of this 100%. Okay, 25% of those who commit violations. So 25%, it's not 25% of the total. Again, 25% of those who commit violations. So how many people are committing violations? I don't know. Let that be X. 25% of these do not receive any penalty. So 25% of X. Again, these are all in percentages, X percent. Right? 25% of this X do not receive any penalty. Okay. Again, table is complete. Statements are over. If you see, this is the equation. 15% plus 25% of X percent is equal to X percent. Percent cancels out. 15 is equal to 75x by 100. X is 20. So you know 20%, okay, commit violations. Okay, now remember this X is percentages because I have taken everything as percent here. So everything is percent. So X is also in percent. So 25% of X percent. Okay, if you want, you can directly assume this as 100. Okay, you don't have to assume this as 100%. You can simply assume this as 100 and solve. Now you see till now we were dealing with numbers and percentages. This question we have fractions. Okay, method does not change. We have 1/3 of attendees who are students, 2/5 again of important are international, half of, right? Non-student were international, what fraction were not international? Okay. Now, as I told you in the previous question, if you want, you can take the total as 100% or assume a value. Similarly, when it comes to fraction, you can either take the total fraction as 1 or simply assume a value. Okay, so I'll show you both. Let's say, okay, we write, so these are students, non-students, total, international, not international, total. Now, if it is a fraction, I take total as 1. Okay, since it's a fraction, I take the total as 1. Okay, 1/3 were students. So 1/3 are students, that means 2/3 are non-students. 2/5 of students were international. So 2/5 of students, not 2/5 of total, 2/5 of students. If you solve that, that's 2 by 15. Okay, 2/5 of students were international. Okay, so this is 1/3, this is 2 by 15, this will become 1/3 minus 2 by 15. Okay, that is, let's keep it in 15 only. That's 3 by 15. Okay, that is 3 by 50. Moving on to next line, half of the non-student were international. So half of non-students, if you solve that, that is 1 by 3. Half of non-students were international. So again 2/3 minus 1/3, 1/3 are non-international. Okay, 2 by 15, 1 by 3, 3 by 15, 1 by 3. What do I need? What fraction of attendees were not international? What fraction of attendees were not international? So I need this total, which is simply 3 by 15 plus 1 by 3, which is 8 by 15. 3 by 15 plus 1 by 3, which is essentially 8 by 15. Okay, so this is how we solve this using fractions. Now, as I said, if you want, you can, right, assume values to solve. Okay, so let's look at that. Right, I hope you are able to see this. Okay, so again we have students, not students, total, international, not international, total. Now instead of taking total as 1, I'll simply take total as a value which goes by 3, 5 and 2, because 3, 5 and 2, okay, because 3, 5 and 2, right, are my denominators. So let's take a value that goes by 3, 5 and 2. So that is simply 30. Okay, now let's just fill the table. So we have 1/3 were students, 1/3 were students means 10 are students, which means 20 are non-students. 2/5 of students were international. So 2/5 of this 10, okay, 2/5 of 10, that is 4 were international, which means 6 students are non-international. Half of the non-students were international. So half of this 20, half of this 20, 10 are non-international. That means remaining 10 are international. Again, if I just do the total, this is 14, this is 16. Okay, what do they want? What fraction of attendees were non-international? So fraction will be value divided by total, right, which is again 8 by 15. Alright guys, I hope you were able to understand the topic. Okay, remember this is a part of our concept builder series. We have just covered two variable Venn diagrams. Okay, in another video we'll be covering three variable and four variable Venn diagrams also. I hope you were able to understand the matrix table method and you understand that how it is super easy, especially in the maxima minima questions. It's easy in all the other questions as well, but definitely in the maxima minima questions. Okay. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.